Good morning, everyone. I'd like to welcome you to our webinar this morning, which is looking at livestock productivity partnership research for Northern New South Wales and Southern Queensland. So I'd like to welcome everyone for coming along. We've got a good bunch of presentations today. And that will give you an overview of the work that's been done over the last 2.5 years or so. Okay, I'll just kick off and to give a bit of a brief overview of what the LPP is and what feed-based research we've been doing as part of the LPP. So the Livestock Productivity Partnership is a collaborative research and development partnership. It's been co-funded by the MLA Donor Company and various organisations, the main ones being New South Wales Department of Primary Industry, UNE, CSIRO, University of Melbourne and TIA in Tasmania. And the main aim of the partnership is boosting livestock productivity and with a real focus on developing new R&D capacity. Okay, next slide. There's three main programs that make up the LPP. The first and largest of those is the feed-based research, and that's what we're going to be talking about today. There is also another program looking at rumen efficiency, and that's more around the market, so the animal side of grazing systems. And then we've got a future farming systems and decision support tools program 3, which is really looking at how the work fits into a system and how we can then present that information through to others. Next slide. So the objectives of the feed-based theme is to develop and commercially validate options to improve year-round feed supply to better meet animal requirements. And there's a few ways that we're trying to do that. First of all, looking at how we can fill seasonal feed gaps. This is a major issue for most livestock production systems. Look for a more versatile feed base to meet livestock seasonal nutritional requirements. So that's really about looking at what feed base we have to supply quality of a high quality feed throughout the year. We're also looking at a more productive and resilient feed base that's matched to the resources and environment. So this is basically looking at the suitability of our different forage options in different areas and making sure that it can persist through the challenging seasons like we've recently had and can also remain productive when we return to better seasons. And the final area is looking at improved understanding of the key soil constraints and then amelioration. So today we'll be hearing about some of the legume work, which is particularly focused around management of nutrition and acidity in the soil as an issue, as an example. Okay, next slide. There's 8 projects currently running in the feed-based program, and they're listed there on the screen. Today we're going to hear from 5 of those projects through different themes. So and we've got the dual purpose crops for lamb production in Southern Queensland, Northern New South Wales that Peter Hunt's leading. The evaluation of new and existing forage brassicas in mixed farming systems that Lindsay Bell's leading, and Lucy Watt will be contributing presentation today. And we've also got increasing the production by integrating tropical pastures into farming systems led by Sue Boschman. Carol Harris will be talking about the improving legume persistence in permanent pastures through better soil management today. Okay, I'd like to introduce our first speaker, who is Lester McCormack. Lester McCormack is a consultant in northern New South Wales after previously working with New South Wales DPI as a research leader, and before that a district agronomist. He's going to give a background around the current and future impacts of tropical legumes in northern farming systems. So this is really giving an overview of the current material we've got out there, and then looking at what research we're doing or needs to be done to address that. So I'll hand over now to Lester to start his presentation. Thank you.
Thanks, Warwick, and welcome to the webinar. My topic is current and future impacts of tropical legumes in northern farming systems. I'll give you a brief outline. I want to talk about the current situation, mention future climate, future research opportunities, and tropical opportunities. On the northwest slopes, the autumns and the springs are becoming less. This is a long-term annual rainfall for Moree, and that's the black line, and the blue line shows the rainfall received from 2000 to 2009, and it hasn't changed. So before the change in autumn and spring rainfall, temperate grasses such as phalaris, temperate legumes such as medics, subclover and white clover were all widely adopted across the northwest and the northwest slopes. However, with the 2000s, it spelt the end of these species of pasture. So we've searched further afield and we looked at hard-seeded legumes, particularly Bicerula and yellow cerodella and arrowleaf clover. These have been, let's say, able to withstand the variability of the season. In 2012, after a tour of Western Australia and talking to Angelo Lui, the twin sowing of both the tropical grass and the legume occurred. So the tropical grass was uncoated, the arrowleaf clover was unscarified and sown with granular inoculum. So this occurred in December, and by end of February we had a germination of all the hard-seeded legumes in the plots. These persisted for over 3 years, and I think I moved on to a different job then and no longer got to follow that up. But that was quite a successful technique of getting some temperate legumes in. And the current situation, research on tropical legumes began in the 1950s, and the search was on in South America and South Africa. It started in the 1950s, and by 1990, 17,000 accessions of 20 genera had been introduced into Australia. Adoption of tropical legume technology around the world was analysed for success, and Max Sheldon et al. Were involved in that project. And they concluded that adoption of legumes was poor. Like grasses, seed supply is also a barrier. Shrubby legumes are now dominating the legume adoption in Queensland, and I think sterile lacuna would fit for New South Wales. And also promising research, even here at Tamworth on Desmanthus, it's showing to be a promising legume. However, I'll just get to the next slide. But this one here is showing lacuna sown in rows and tropical grass in between. This was at the 2009 Goondiwindi conference. And what I was going to say about Desmanthus, in northern New South Wales, it acts as a legume. An annual legume because of frosting. So it comes back from seed, it produces a lot of seed, and it's very resilient. Our future climate is predicting to be hotter We're already breaking climate records. Hottest day on record was beaten on 2 successive days, 40.9 and then a 41.9. And that was thanks to Professor Mark Howden for the loan of that slide. The tropics are moving south, so we're going to be more like north of us, and for Tamworth, that's probably a Warialda climate in about 2030. Research will add to our agriculture's adaptability in future climate. As I said, the future climate, the tropical temperatures are moving south, so we need to be ahead of it. Rainfall events are going to become more erratic, basically storms. Future research, what should we be looking at? We need more legume options and more focus on legumes for light acid soils, because that's predominantly the northwest slopes. Seed production is almost a lost art. Macadamias and avocados are taking over, and although Atherton Tablelands is still a seed production area, it's also prone to cyclones, and we're probably predicted to have more of those. Also, there has been some seed production in Katherine under irrigation, so that might be worth pursuing. We need R&D, but to capture the benefit of the research and increase producer productivity, we will need to work on adoption to realise the value of that research. And we look at some tropical opportunities. This year, we had good January-February rains, and it was ideal for producers to cash in on seed production. The tropical grass didn't have to be mown back to get them to increase tiller production and come in evenly, because all paddocks were grazed down quite low. However, there was a wide range of seed quality, which was a little bit disappointing, but season and maturity influence, plus the timing of harvest. These opportunities increase our tropical response, so we're able to have more seed to spread around. Legume or a fertiliser? I'm told by some people we should concentrate on legumes. We should try just putting out fertiliser, but we have a much better pasture if we have a legume present. And I'd just like to thank you for your attention.
I'd like to introduce our second speaker for the day, who is Suzanne Boschner. Suzanne is a senior research scientist with New South Wales DPI. She's got a long history of tropical grass research and is one of the leading experts in Australia in this field. And she'll be talking about the tropical pasture research that is part of LPP, and this is the largest project that is part of the LPP program. And so I'll hand over to Suze to give her presentation. Thank you.
Hi, Warwick. Thank you very much, Warwick. And hi, everyone. Thank you very much for joining our webinar today. So my presentation, or the project that I'm going to be speaking about today, is about increasing livestock productivity with tropical pastures. Next, please, Liz. Now, Lester's already set the scene with regards to our climate and how it's changing. Our temperatures have been increasing. Our rainfall is certainly, or our weather is becoming more and more erratic. And that's actually predicted to continue going into the future. So what that means, though, is that our production systems need to be a little bit more flexible to be able to handle that variability. But in southern New South Wales, or in some more southern environments, which are based on temperate species, the prediction for them is that they will actually there will be an adjustment to the distribution of their rainfall, and they'll end up with a shorter growing season of their temperate pastures, and which will give them a longer summer, early autumn feed gap, which potentially they're going to have trouble filling. So that's where they're going to be looking for. They're going to need new options, of which are responsive to summer rainfall, of which tropical pastures are certainly an option for them. So that's where our project fits in. So the project involves research which has been conducted across the entire state. In the south, it's about looking at opportunities for tropical pastures in that environment. Well, in the north, we're actually going to be building on our research, looking at tropical legumes and how to utilise our tropical pastures better. Slide, please. So there are 5 objectives to this project. It's looking at the areas which are suitable for tropical species and their fit within our farming systems, looking at the benefits at a whole farm and system of these species, also looking at establishments. So down in the southern part of the state, or the further south you go, there are issues with establishment because rainfall will be declining and more erratic when we be looking to establish our tropical pastures. Developing regional agronomic packages, and also enhancing the companion legumes and their management. And it's those last 3 that I will be basing my presentation on today. Slide, please. As part of the project, we've been doing some modelling, looking at the potential distribution of a range of different tropical species in our current or near past environment, and also into the future, where the potential distribution would be. So looking at the figure on the left-hand side, this is for Rhodes grass. You can see that the potential distribution for these species is actually, or for Rhodes grass, is actually larger than where we're currently sowing it. But when you have a look at the potential, looking at 2030, you can actually see that a lot of those higher rainfall, higher altitude areas up on the tablelands, northern tablelands, also central tablelands, they're going to become more suitable in going into the future. Slide. We are to test some of that modelling. We've sown a range of different experiments in a number of locations, ranging from Glen Innes in northern New South Wales down to Wagga in the south, and out as far west at Condobolin and Gilgowie. Now we've got 10 tropical grasses which are evaluating in all sites, and we've got a couple of Desmanthus cultivars, and we've also included a couple of temperate species in there as well, as a bit of a comparison. Slide. Just as a snapshot, this is just go straight to Glen Innes, since it's actually the north is the focus for today. So this Glen Innes experiment was sown in 2018, and it was, I guess it's sort of struggled or limped along for the last 2 years due to the low rainfall. The rainfall figures for Glen Innes over the last year, to 2019, was the driest on record, with about 350 millimetres received, compared to 850 millimetres, which is the long-term average. So it's, these grasses have been doing it pretty tough. But with the rainfall they received early this year, there was excellent response of a number of species, and they're the ones which have also been the most persistent to date. And they include the Gatton and Megamax 059 Panic, Benbatsi Panic, Digigrass, and Paspalum have probably been the best performers. Slide. We've been conducting some workshops to understand what producers like, or the advantages and disadvantages producers see with their tropical pastures, and then use this. So we've been doing this with producers in the north, and also speaking with producers in the south, to find out what sort of information they required before they'd start trialling tropicals. And it was just interesting, the lists which are on the screen at the moment, they are, I guess, some of the advantages and disadvantages, or the drivers and constraints to tropical grasses, which were identified by people in the north. And it's not surprising to see that things like difficult to control weeds, they're responsive to summer rainfall, which we certainly saw at the beginning of this year, and that resilience, which is a pretty important characteristic, or one of the things we love about tropical pastures. But look, seed availability and seed quality are certainly ongoing issues. Seed availability during the drought was a major issue, but hopefully now that we've had a decent season last year, there will be more seed available. But again, it's also wherever you're buying seed, please check your seed certificate. But I guess just a pertinent point, considering there's a lot of people probably interested in sowing some tropical pastures this year because the forecast is looking pretty good, the seasonal forecast. Just make sure that if you are going to sow tropical pasture, make sure that you're sowing it into a paddock which is free of summer grass weeds, and sow your seed shallow, because that's where a lot of our pastures are lost. Slide, please. Within the project, we've been doing some work on establishment success. This has been through some modelling. I've only shown a very small proportion of the data set here. Again, just trying to focus on very much the more northern type work. But so this is actually work. So across the bottom of each of those figures, you can see 7 months. That is actually what we considered to be the establishment window for tropical pastures. And up the left-hand side, we've got the frequency. So over a 30-year period, and for the figures which are shown here, our 30-year period is from the summer of 1989-90 through to last year. In the Tamworth, using Tamworth rainfall data, 94% of years, or 28 out of those 30 years, were actually suitable for establishment of tropical pastures. But the majority of them actually established in the month of November, or that was the first establishment opportunity. Now, when you go a bit further south, looking at Cowra and Condobolin, the likelihood of success wasn't as high, but it was still pretty good at over 70%. But you'll notice that the peak, I suppose, of when the maximum we are likely to get the greatest emergence events was actually over that November through to January period, which was interesting. Now, Kim, when she was doing part of this work, actually looked at the role of cover. So looking at, say, a forage oat stubble, sowing into a forage oat stubble, because it has the advantage of being able to keep the soil surface moist for longer, providing a better microclimate for establishment. What Kim's work found was that in Tamworth, it didn't really make much difference on this particular soil type, but in a lot of the other areas that we modelled, it actually shifted that peak from earlier in the growing season. So it actually gave more opportunities for establishment. Slide, please. We've also done some establishment and seedling work in central New South Wales. So the team looked at sowing tropical grasses in spring, summer and autumn, a single sowing day in spring, summer and autumn, and they found that they actually got the maximum establishment in spring and autumn, while summer was quite a bit lower. Now the guys also had two levels of stored soil moisture. So high, we're talking about accumulating lots of soil moisture to be able to establish your pasture versus not having very much at all. And they, at 6 weeks of age, they actually labelled some seedlings and then followed those through for 14, nearly 18 months. Now there was no effect of that stored soil moisture on the establishment. But what they actually found was that there was quite a long-lasting effect on the survival of those seedlings. So if you have a look at the table there, you've got spring. For spring, we've got high stored soil moisture. 91% of those seedlings that had emerged at 6 weeks of age, they actually survived. 14 months later, they were all still there. While where there was a low stored soil moisture, only 60% of them had survived. Now, the effect was not as obvious in autumn, but I think it clearly shows the value of having that high stored soil moisture and the value of it. Slide, please. Now, moving into legumes, Lester was talking about the role of tropical legumes. Yes, in northern New South Wales and southern Queensland, we've actually got the advantage because of our rainfall event. Because of our rainfall, we've actually got the opportunity of both having the temperate legumes, so things that grow over the winter period, and also our tropical legumes. And it's just choosing which one is going to be best suited for your soil type and for your enterprise. But each of them comes with its own set of advantages and disadvantages. Slide, please. As part of this project, we're actually having a look, we're trying to get a better understanding of lucerne and how to utilise lucerne in a mixture. It is the best of our temperate perennial legumes, but it doesn't tend to, or rather it is extremely competitive against or anything it's growing with, including the tropical grass. So in this experiment, we've changed the distribution or the proportion, sorry, of lucerne in a pasture. So on that figure, you can see L0 through to L100. L0 is where there's no lucerne, through to the L100, which is 100% of lucerne. You can see that is the total production for the period from January 19, when we established the pasture in that 18-19 summer, through to August this year. Now the green hump over the top. You can see how it actually is raised. If there was no advantage of having the mixture, then that line would actually be straight. But the fact that it's actually raised means that there's actually increased production, overall increased production, by having a small amount of that lucerne in the mix. Now, one of the advantages that we've actually found from this study, or we've been able to quantify, is that the digit lucerne mixtures actually capture more rainfall than pastures which are dominated by lucerne. So if you look at the table at below, where you had 25% or less lucerne, we were able to capture, so this is from data which was recorded from summer, this last summer. I think we had something like 237 millimetres, 237 millimetres. We captured almost 60% of that rainfall in the soil. 4 tonne of dry matter was produced at that particular time with really good water use efficiency. In contrast, where we had over 75% of lucerne, we only were able to capture and store in the soil, store in the soil 16% of that rainfall. We got half the production and very poor water use efficiency in comparison. Next slide, please. A legume that Lester spoke about, Desmanthus, and Desmanthus is certainly a legume that we're pretty excited about and see as having a role in a greater role than what we currently see. So as part of this project, we're actually doing a range of different studies to investigate the seedling competition. We're looking at different ways of establishing legumes into both sown and native tropical pastures. So we know we've got a lot of tropical pastures which don't have a strong legume component. That's New South Wales and Southern Queensland. So just looking at different techniques to be able to re-establish those legumes into those pastures, and then grazing management to be able to try and maintain them in the pasture for longer. One of the deficits, I suppose, with Desmanthus is that there are very limited herbicides which are registered to control weeds. So we've actually done some work to investigate that. I think Spinnaker is the only thing which is registered for use in both New South Wales and Queensland. So our aim is, we've provided a list of different herbicides here, which we've found to be effective. So as a pre-emergent during that establishment year, and also for older pastures. Now, these are certainly not registered at this point, but our plan is to submit permits to APVMA for their use in both Queensland and New South Wales. Slide, please. A Leucaena is another legume which we're interested in, and Lester also spoke about it. One of the things that raised quite a few eyebrows over the last few years during the drought was Leucaena, because it was the only perennial forage legume, or forage, full stop, perennial forage, which was green in the landscape. So you drive along and just see this green, which was Leucaena. So its ability to be able to access water and produce some forage when everything else, some feed when everything else wasn't, was pretty spectacular. Look, it is slow to establish, and there are consequences, long-term, ongoing consequences if establishment is not done correctly. So it needs to, the time and planning needs to be taken into consideration. But we found that even in New South Wales, it's certainly highly persistent once it is established. You need to be very aware, I'll just make a note that of its weed potential. So in New South Wales, DPI are not recommending Leukina at this point. However, we are pretty excited about the sterile and seedless lines which are being developed in both Queensland and WA, and looking forward to evaluating those in New South Wales. Slide, please. Fodder conservation is another area which we're interested in doing some work. How often do we have all our, we get a summer storm and all our pastures respond together, and before we know it, it's, we put stock on some, but there's other pastures which sort of run to head and we don't get to utilise them as we would like. So fodder conservation is certainly an opportunity where you can actually harvest that production when it is at its peak, and then store it for use in other times of year or during drought. And also bring that pasture back into a veggie state, so then you've got something fresh and high quality food to put your animals on. So as part of this project, we're also going to be looking at fodder conservation for silage production, and fermentation is key when it comes to making silage. So tropicals on the whole don't tend to ferment as well due to their high fibre and low water soluble carbohydrate. So we're going to be, this year, we're going to be looking at the role of inoculants as part of that. Slide, please. We're not doing any work on pasture dieback within our project, but I thought this was a good opportunity just to raise awareness for anyone that wasn't familiar with pasture dieback. Dieback is a condition which is decimating grass pastures in both Queensland and now also in New South Wales. It affects sown and native summer grass pastures, and basically all the sown tropical grasses that we have that we sow in New South Wales are susceptible. Slide, please. It was reported on the North Coast, New South Wales, in March this year, but it's certainly not a high rainfall condition. If you look at where it's distributed across Queensland, and it is very widely distributed from the Atherton Tablelands right down to, now into New South Wales. But it can be found, it's commonly found in areas which have about 600 or more millimetres of rainfall a year. So that means there's quite a large area of northern New South Wales which is also susceptible in the short term. Slide, please. DPI are recommending, or just asking producers just to keep an eye on your grass pastures. If you notice any sudden changes, keep an eye on it, try and eliminate what else it could be. Maintain good farm biosecurity, so who comes on and wanders around your property, keep good records. There's been some reports of dieback coming from grass hay. So if you have grass hay which has come from a dieback known dieback area, monitor where it's being stored and also areas where it's been fed out. If you'd like more information on dieback, visit the dieback pages on New South Wales DPI website, also QDAF's Future Beef or MLA. If you're in New South Wales and you think you may have pasture dieback, please ring the Exotic Plant Pest hotline on the 1800 number shown on your screen, or please email the biosecurity email, and we'll get someone out to have a look and to speak with you. If you're in Queensland, you've got any questions or queries, please contact the DAF Customer Information Centre. Slide, please. Lastly, but certainly not least, Warwick commented that this is a large project. We've got teams stretched across the entire state, and it is, look, it's a credit to the team under the conditions we've had the last few years that we've been able to get as much done. So I just want a huge shout out for both the science and technical teams which have supported this project. Thanks, Warwick.
Righto, thanks, Sue. Good presentation there to give us an overview of the vast amount of work that's going on, and particularly, I think it was really good to give us that quick update on pasture dieback as well, which is obviously an emerging issue that we have to be aware of in New South Wales, and is obviously been impacting people for a while in Queensland. Now, just like to see if anyone's got any questions. Just remember you can enter those through the Q&A tab on your, and we can ask those to Sue. Here we go. Looks like we've got one coming through now. From Bill Davison, how much water does Lakina use in a mix with tropical grasses? How does the water efficiency of this mix compare with straight tropical grass pasture?
Yeah, good question. We've just finished an experiment. We're in the process of going through the results at the moment. I think it actually varied with season and with year as to how Lakina performed. So we had where Lakina actually came into its own was actually during the peak of the drought, where all the other pasture that we were evaluating actually stopped growing, and Lakina continued to grow. So on I think normal years it was probably maybe on par or a little bit, or so the Lakina digigrass mixture was probably on par or a little bit less than a pure digigrass, which had been fertilised with nitrogen. But during that the droughted period, it actually was more efficient.
Okay, thanks. Next question from Tom Amy. Would you include Soteria? I found it more cold tolerant than Rhodes grass and Panax.
Yeah, look, good question. At the time when we were trying to pull together species to include in this in the evaluation, yeah, we weren't able to get any seed of Soteria. My experience, I actually tried to grow Soteria at Tamworth. I don't know, it was possibly 10 years ago, so maybe it's obviously something maybe I should revisit. We actually didn't have any success with Soteria. Our experience was that Rhodes was better than Soteria. But look, it's a fair point. It probably is something where we need to go back to basics and pull out, you know, look more broadly at more species. If we're moving into new environments, then we need to give everything a fair shot. What we have tried to do is probably get the ones which are reported in the literature as being more, as having better cold tolerance. But yeah, look, fair point. We probably, I expect in the future we will be doing more evaluation, and we will certainly look at including Soteria in those.
Okay, another question here from Jared Doyle. How did you establish the lucerne in the tropical pastures? Were they sown together or separately, and in which order?
Yeah, look, really good question. We've in the case of our on some of our more recent work, we've actually been sowing the lucerne and the grass, the tropical grass at the same time. So in spring, in November, going in sort of late October, early November, just sort of gives the legume a bit of a go before it gets too hot. We have actually tried sowing the grass and then putting the legume in the following autumn, and that will work. We've also tried putting the lucerne in first and putting the grass in, so putting the lucerne in autumn, and then the following spring sowing the grass. We haven't actually found that to be particularly successful. Probably the best way we've found is actually when you sow the two of them together in spring, because if you sow them, whichever one you otherwise sow first, it's the one that gets first dibs on resources, and then the other species, second species, then has to compete very hard in order to be able to establish well.
Okay, just one last question, then we'll move on. Are you investigating annual legumes, e.g. half-seeded legumes with tropical grasses?
Yeah, good question. So as part of a previous MLA funded project, we looked at a range of different temperate annual legumes. Of those, the legumes which were most successful for us were actually medics and also woolly pod veg, interestingly enough. So but on the particular sites where we had these, they were not highly acidic. So we didn't actually get to see the benefits of the Bicerula and Ceradella. But I do know of other producers that have them, grow them well, and they certainly play a major role in the legume component of their pastures.
Righto. Thanks a lot for that, Suze. That's great presentation, covered a lot of material there, and I think some really good questions from the audience as well.